So, on pressurization. Pressurization systems rely on providing that high pressure from an uncontaminated space to create that large pressure difference across that barrier. You're ideally just across the barrier separating from that rest of the building for the fires growing to try to compartmentalize that. Useful a lot, sometimes pressurize a path of egress. You're going to pressurize that egress corridor, maybe in lieu of, in addition to it being rated or fully rated. Maybe also protecting those multi-floor penetrations from from being a smoke highway. From just shafts are very scary when it comes to smoke because you have completely removed all horizontal assembly, all barriers, everything else. That's why there's so many rules sometimes in the model codes around your shafts, around your penetrations to your shafts, and holes in those horizontal barriers, because that keeps the smoke on the floor. And as soon as it hits an unprotected shaft, it's popping right out the building, and you can have people lose their lives that are many, many floors away from the building. I think it was the MGM fire, 70s or 80s, where they had a fire in the electrical room or a fire down on the first floor, and it ended up killing a bunch of people at the top floor due to the smoke movement. And that was actually, I think, the impetus for your horizontal assembly and your barrier sealing. A lot more focus on sealing those holes in the horizontal barrier. When you are designing such a system, you need to be maintaining a minimum design pressure under all conditions. So the interior and exterior should be evaluated, the summer and the winter should be evaluated, your temperature extremes. You need to design for the minimum condition, and you may not know what that minimum condition is until you've run through all the different calculations. So sterile pressurization, we talked about general pressurization, we've talked about stack effect. It all leads to sterile pressurization. This is our real almost first type of smoke control system. Sterile pressurization takes that element and buoyancy. It is recognized by the International Building Code for you use pressurization in lieu of stair lobbies or elevator lobbies. They're usually found a lot in high rises, these pressurization systems. Due to that vertical variance of factors, that pressure profile can change. So we're talking about sometimes your leakage values into your pass into out of the shaft. What holes are there, what ways can air and or smoke leak through into that shaft, how big that shaft is, how much air can it move, how much temperature, thermal lag is going to be in the shaft. Are there other shafts in the building? Actually, the presence of multiple shafts can affect that movement quite a large amount. And then is there shaft venting? Are you introducing outside air directly into the shaft? Obviously talked about in pressurization before is that flows the top and the bottom on almost an equal curve. That's just the attempt to even out that pressure imbalance within the building. If you end up pressurizing a shaft, you do have to pay attention to how that pressure distributes within the shaft itself. In that air is pumped into the shaft is subject to stack effect, which is caused by that pressure difference in that stair shaft. So that hot, cold air may not rise or fall, depending on what you want to do, as easily as you may think, due to that pressure difference between the air being pumped in and the air already present in that shaft.